Okay, we are 3 minutes past the hour, so I think we can start. First, I wanted to ask for feedback on my audio. Is it fine? Can you please reply on chat or unmute yourself and tell me? Audio quality is fine? Yeah, okay. Very good, thank you. Okay, so okay, let's get started. So for this presentation, so I'm going to first do the first 15 minutes, and then we will stop for questions. So in the first 15 minutes, I will just present Jetstream and show you a way of running virtual machine on Jetstream, basically using the simpler interface. And then we will stop for questions. So if as we go, you want to write questions in the chat, then I will stop and look at them. And then after that, we'll start the tutorial part where we will be using the command line tools to deploy Kubernetes and JupyterHub. So this is yeah, and then in that section you can I will monitor the chat for questions, so you can ask the questions as we go. Okay, so let's get started. So you can get the slides at this address, okay, if you want to follow along with that. So let's first talk about Jetstream. So Jetstream is within the Ecss supercomputers, is the one that is more, it's not a traditional supercomputer, but it's the cloud deployment. So basically very similar to Amazon, the Amazon cloud. And it's hardware-wise, it's 320 nodes per site, and it's 2 sites, one at Indiana University, which is the one that we always use because it has a newer version of the Openstack software, and then each node has 48 cores and 120 gigabytes, and has the KVM, which is an hypervisor that gives you the possibility of running multiple virtual machines on each of those nodes. So you can decide on the size of the virtual machine that you want, and the OpenStack software, which is handling the cloud environment, can provide this virtual machine. And once you have this virtual machine, so you see down here, with this virtual machine, you can choose the image you want to start from. So generally the Linux distribution, you can choose the size between a tiny machine that has only 1 CPU to extra large machine that basically is a full node. And then once you have that, this the OpenStack software creates this virtual machine and then gives you root access. So you can then do anything you want on that machine, and then you decide when you want. So there is no limit on it's not like a Slum reservation where you have a limit. You can just keep running whenever you want, and then you are charged based on the size and on the time that you keep it running, and you have an allocation. And if you are an ECSS consultant, you already have access to an allocation, so you can just use the location. The PI is Bob, and you can use Jetstream straight away. Okay, so the first way of using, so the point is, how do you request this virtual machine? And the simplest way is to use the Atmosphere interface. The Atmosphere interface is a web application and is a very polished interface, very easy to use, it's really great. And from here, you basically log in with your Ecss account, and then you choose what kind of machine you want. So first, you choose an image, okay? So you have CentOS 7, you have other, you have some pre-configured image. For example, if you are doing bioinformatics, there are images with already all the bioinformatics tools. And a very generic one is this one, the latest stable Ubuntu, one of the latest stable Ubuntu with also the Docker environment. And this is interesting because if you think there are several layers. So you have these nodes on Jetstream, and then inside them you are the OpenStack Cloud software creates a virtual machine, and inside that virtual machine, you can run Docker containers, okay? And so you can install a generic image like this Ubuntu, and then bring your own software via Docker, okay? And with this web interface, then you have a few configuration options. The most important is the instance size, okay? So you have an allocation that's basically based on the number of CPU hours, okay, of the number of CPU hours. And so if you use a tiny image, then you are charged just 1 CPU hour per hour. And then if you have a very large image down below, then you are basically using the full node to yourself. And yeah, okay. So once you have this image, so you request the image via the web interface, and then you're gonna get an email confirmation that that image is ready after a few minutes. And then you have the image is also assigned a public IP. So you can SSH into that image with your, and it's automatically mounting your Ecss home for your Ecss SSH certificate. So you can just SSH into this machine, or you also have a web terminal that you can use directly within Atmosphere to get the terminal access to the machine. And then you see here that we have this Ubuntu machine, and then you can use root access. Okay, and I think this is a pretty nice tool that that all ECS consultants have available, and there are a few different usage scenarios that I think could complement the work of ECSS consultants. Okay, for example, happened to me that there are some Docker containers that I want to use that are too big for a laptop. Okay, and so you can get, for a few hours, you can get a virtual machine on Jetstream, and you can load the Docker container there, and you can connect to it remotely, and have stuff run over there. Okay. Another thing, of course, is deploying web applications. So if, as part of a project, you are required to have a web application that could be even a gateway, but even simpler web applications that are providing some data visualization or something like that, then you can get a machine through Atmosphere, install a web server, and then deploy your web applications. Or you can run Jupyter notebooks on a single server. Okay, so we'll see later how you instead use Kubernetes and JupyterHub to do a distributed setup, but for now we are focusing on a single machine. Okay, this is like the basic usage, some basic usage scenarios for Jetstream, and or you can use this as a shared environment where someone can maintain a software environment and people can connect to that. Okay, but still it's just a single machine, so resources are a bit limited. Or there are also, you can use that to deploy a commercial software that has a license, so that some people can connect to that and use that that software. And another pretty interesting thing is that within the Atmosphere interface, there is also the possibility of running a software, a GUI through the browser. So you basically log in with your browser to Atmosphere, and then you can have you can really visualize the desktop of this virtual machine in your browser, and you can use a software which is meant for a desktop environment into Jetstream. And so to get started with this, so if you are an ECSS consultant, you have already this allocation, and if you are not, you can go through the Ecss website, and you can request an allocation on Jetstream, and once you are granted this allocation, then you can create machines with on Jetstream through the Openstack software, which is handling all of this resource creation and networking and everything else. And another useful thing is that also provides persistent storage. So once you have created a virtual machine, you with already some local disk space available. So you see here there are generally machines that 60 gigabytes, but there are some type of machines that are storage optimized. So you see that the ones which start with S1 here, they have a lot more space. But you can also attach additional storage to your machines, and that storage is automatically mounted on your machines. And you can get a machine like this, and then you can attach 1 terabyte storage if you have requested that into your Ecss allocation, so that you can store a lot of data on that instance. Okay. Okay, very good. So this is the end of the first part of this tutorial. So I'm gonna stop for questions. I'm going to look at the chat first. Okay, see there are no questions. So if anyone has questions and wants to unmute themselves and ask them, otherwise I'll wait 1 minute and then go forward.
I have a question about the remote desktop option.
Yeah.
How well does that actually work in terms of the screen resolution and in terms of any lagginess for somebody actually trying to run a GUI-based application?
So I remember Jeremy Fisher doing some tests. So it's really optimized. So it's based on, it's using Guacamole. So you can look for the Guacamole environment. And I remember Jeremy Fisher testing that with very slow connections, and it's pretty optimized. So it does a lot of compression on transfer. So it's, but yeah, I don't have any more insight beside that.
Okay, thanks.
Yep. Okay, so I'm gonna take a look at the chat. Okay, so yeah, about spinning instances through the API, we're gonna look at that later, just the second part, and then so the cost. So you can Google for. So there is no limit on having a virtual machine running. Okay, so once you have started the virtual machine, you decide when you want to tear it down. Okay, you can even have it running for a year. Okay, and about the cost structure, so I actually have built a cost calculator to compute the cost. So where was that? So I think I don't remember if it was on a GIST. Yeah, so let me just see if I can find it immediately. Otherwise, I will send. Let me see. Oh, I go to my GIST. Okay. Yeah, so I have a cloud calculator. I will circulate the link. I think I shared that on Twitter if someone wants to look at that. So my username is Andrea Zonca. Okay, I cannot find it now. But yeah, so there is basically hourly cost for each instance, and then you can do your own computation and see. So if you Google for that, you should be able to find it. Okay. So about the difference between virtual machine and container, yeah, I think we'll focus on that later on in the second part. Okay. So, but the virtual machine is not a container. So I think you can run a container inside the virtual machine. So a virtual machine is basically like your own server. Okay, so like you have a desktop in your office, in your SSH into that desktop, okay? And so you have full access to that desktop. This is kind of similar. So they have this nodes on IU, okay? And within that node, they create, let's say, a tiny machine for you. So one core is dedicated to your just for your machine. So this is basically creates a small server which is running inside this node, and you have you have a subset of the RAM, a subset of the CPU, a subset of the disk just available for you. You can keep running on that as long as you want. Okay. Okay. Okay, very nice. Okay, let's go ahead. Okay, so now in this second part, we will step up and focus on running a distributed application. Okay. So just to have a usage scenario in mind, okay, is let's say that we want to have some Jupyter notebooks to deploy for a workshop. So you have a workshop at your institution, you have 50 users, and you want to give them a good resources. So let's say 10 gigabytes per user. So if you want to give 10 gigabytes of RAM per user, then you're never going to fit on a single machine. So you need multiple virtual machines. Okay, and then you want to be able to automatically or manually scale up and down based on demand. Okay, so the day of the workshop, you want to have resources for everybody, plenty of resources for everybody. But maybe the days before the workshop where you're just testing stuff, then you want a subset of that because you don't want to spend a lot of resources because you are paying for the active machines that you have. So you want to have just the machines that you need to. Okay, and so we want what we want to is a system that can help us manage this distributed application. So running stuff distributed is not an easy task. Okay, so you have think about, I don't know, 10 servers. Okay, 10 separate virtual machines that are running on separate nodes, each with their own IP. Okay, and then you want to launch services. So some services are gonna run on one machine, some services on another machine, and you want to be able to coordinate all of this. Okay, and you want to have resiliency. So if something fails, you want to rerun it. You want to be able to monitor what's going on. You want to be able to quickly access at the logs of all of the services that are running without SSH around on all of the machines and looking for stuff there. Okay, and then you want to handle networking, and all of these features is exactly what Kubernetes does. Okay, so and so what we want to do is we want to get a few virtual machines on Jetstream, okay, and then we want to install Kubernetes on those machines, okay. So and then we interact with Kubernetes. So we don't care exactly where the services are running, or so we don't care individually about all of the services. We just ask Kubernetes, please deploy a web server on this cluster of machines, and then Kubernetes handles everything for you. Okay. Now, okay. So for these sections, so we will be going through installing Kubernetes on Jetstream, and then installing JupyterHub on top of Kubernetes. And during the webinar, I'm going to skip some steps. Okay. So I want to show you basically the most important things and just give you the feeling of how this works. But I have a step-by-step tutorial. So if you want to reproduce what I'm doing, okay, you should go to this link and follow the step-by-step tutorial. So I have configuration files for everything, and I explain all the different steps. So I'm sure. So after watching this this webinar, I think if you want to reproduce it yourself, you should follow this tutorial step by step. Okay. And then if you have if you're interested in related stuff, then I have a lot of other tutorials. For example, deploying Dask or deploying a monitoring a service to have a graph of your resource usage and all of that with Grafana. Then you can look at all the other posts there. Okay, very nice. Okay, so first step now. What we do is we can run the OpenStack command line tool. Okay, so basically what we saw before, instead of asking OpenStack to create a virtual machine using the Atmosphere web interface, we can do that from the command line. Okay, so you install this command line, the OpenStack command line tool. Okay, which is based on Python, and then you follow the instructions from Jetstream on how to automatically have authentication. Okay, and then from your desktop machine, from your laptop, you can drive the virtual machines on Jetstream. Okay, for example, you remember that drop-down menu that was showing all the different kind of size of the machine. So those are called in OpenStack parlance. They're called flavor. Okay, so you can do it from the command line. You can do OpenStack flavor list. Okay, and this is you're gonna get the list of all the available sizes, and you can create, for example, if you want to open ports, so you see the command line tool is very well organized based on all the kind of resources that OpenStack can handle. Okay, for example, security groups are used to manage open ports, basically. Okay, so let's say that you want to create a web server, so you want to open port 80 and port 443 for HTTPS. Okay, so you do this from the command line. You create a resource security group, which is named HTTP_HTTPS, and then you add some rules that say basically open port 80 and open port 443. Okay, and then once you have this security group going, you can attach this to running OpenStack virtual machines. So you create, and then another thing, I don't show a real example because it's very complicated, but you can do OpenStack server create. This creates a virtual machine from you from the command line. Okay, so you give all the different options. So you want to install some key pair so they can SSH in, and this is an argument. And then you choose the flavor, and then you choose the image that you want to use. Okay, so you pass all of those arguments into OpenStack server create, and this is very, very similar to doing this on the OpenStack, on the Atmosphere web interface, the one that we saw before. Okay. Okay. So okay. So I have a terminal here, and so I'm authenticated on. I am authenticated, so I can do, for example, OpenStack server list. Okay, and here I'm gonna show what are the virtual machines that are currently running under my account. Okay, so you see OpenStack prints out the machines. So you see this is the name of the first machine. It's a Fedora Atomic. Okay, and I have these two, and then it's giving me the IP addresses, the public IP addresses. Okay, or I can do, for example, OpenStack security group list, I think. Okay, these are the security groups that are created. So you see, for example, here, HTTP, HTTPS, the group that we saw before, or you can, so when you do OpenStack server list, you can also dig deeper into the different resources that are available. Okay, so this is basically, here is basically from my laptop. Okay, so I'm on my laptop and I'm running commands and I'm getting answer from the OpenStack API. Okay, and so I can do OpenStack server show, and I can show all the details of the server, of my master, of my Kubernetes. We'll see later exactly where that's coming from. So you see here is this is all the details about that machine. Okay, so for example, the security groups that are activated. So for example, you see that I needed the web server running here, so I attach the group HTTP_HTTPS to this. Okay. Okay, so this is some example on using the OpenStack command line APIs. Okay, I'm going to check if there's any question on this. Okay. Okay, so so for now everything is running on a single node. Okay, so each server we create is a separate virtual machine. Okay, that's running on some nodes on Jetstream. Okay, and you can create multiple servers. You can have a lot of servers running. The problem is that there is no easy way to coordinate those servers together right now. Okay, so that's why using the OpenStack command line requires some automation on top of that to make it really useful, I think. Okay, and that's what we're gonna look at next. Okay, okay, I'm gonna check chat one time. Okay, very nice. So now, so we want more automation than that. So what we'd like to do is we want to have Kubernetes running. Okay, because Kubernetes allows us to treat have a single point of we can create more complicated setups and distributed services using Kubernetes, and all the community is using Kubernetes, so it's a natural choice. Okay, for example, the Jupyter team, thanks to the Zero to JupyterHub project, is a project that provides you with a recipe to deploy a JupyterHub on top of Kubernetes. Okay, and that's basically their recommended way of deploying a distributed setup of JupyterHub. Okay, because can rely on all the Kubernetes features to provide a lot of low-level stuff to keep a distributed system running. Okay, and we are very lucky that OpenStack has already a way of deploying Kubernetes automatically. So there is an OpenStack command, okay, command line, part of the command line interface, which is used to create a Kubernetes cluster, okay? And it's called OpenStack COE, okay? COE stands for Container Orchestration Engine, okay? And Kubernetes is a container orchestration engine. And basically, what you can do is you choose the number of nodes that you want, the number of master nodes, the number of worker nodes, and then all the different, there are a few more configuration options based on the size or on the flavor of the machines that you want to use. So you want extra large machines or you want smaller machines, and then you want to choose how you want to handle the persistent storage. And okay, so for all the details, please refer to my blog post. But basically, what you do is you do OpenStack COE, okay, for container orchestration engine, and then cluster create. So the cluster is a cluster is basically a Kubernetes cluster, which is running inside your OpenStack container, your OpenStack platform. Okay, so what this is actually doing is creating a number of virtual machines. Okay, and then those virtual machines are running all the Kubernetes services. Okay, and after we have Kubernetes running, okay, then instead we won't be using OpenStack much anymore. We have another command line tool which allows us to directly interact with the Kubernetes API. Okay, so here is a graphic on how this works. Okay, so once you have that, so you launch this command, and then OpenStack is gonna, it takes maybe 15 minutes or something. After 15 minutes, you see that there are some servers that are running, some virtual machines. And you see each virtual machine has their own Docker environment, okay? And so the Docker environment can run Docker containers, okay? And Kubernetes is managing all of those Docker containers, okay? So Docker containers are running on more workers. So here we have a setup with one master and two workers, okay? And the setup that I have running on here instead is just two, okay? You remember that OpenStack server list gave one master node and one minion. So they call it minion here, but they are the worker nodes. Okay, so you see here the master node that has master in the name and the minion. Okay, so the master is special because runs the key services. Okay, and then from your laptop you can choose what services you want to launch in your Kubernetes cluster. Okay, and so okay, so let's take a look at what so some of the features of Kubernetes. Okay, so this is basically, you remember that a few slides back I was saying, oh, what do we need to deploy to administer, to manage a distributed system? We need some features, okay? And these features now are, they are linked to the actual way that Kubernetes implements that, okay? So we want to configure and launch services, okay? And so you can write YAML files, then tell Kubernetes what container, what Docker container you want to run, okay? For example, you want to run a web server, so you have your NGINX container, okay? You into this YAML file, you specify which version of NGINX you want to run, and then all the configuration options, and then pass it to the kubectl command. Okay, so kubectl is basically the way to interface with Kubernetes. Okay, so it's the same. So you use OpenStack, the OpenStack command line tool when you want to run OpenStack commands. Okay, so basically the underlying structure. Okay, but then once you actually want to interact with Kubernetes, you use kubectl. Okay, so for example, you want to scale some services, you want duplicate services, you want more power, then you use Kubernetes. There is a command for that, which is kubectl scale. Okay, and then one of the best features of Kubernetes is how it handles networking. Okay, so you can have internal IPs, and you can expose services internally or externally, and it doesn't matter where they run. Okay, Kubernetes makes all of the networking automatic. Okay, so you have a web server that is running on some node. Okay, for some reason that node dies. Okay, it's disconnected. There is some maintenance or something. Okay, and then Kubernetes has the feature of relaunching the servers. Okay, so if one of the virtual machine, the underlying nodes, the underlying virtual machine dies, okay, all the services that were running there are going to be automatically recreated elsewhere in the cluster. Okay, and then all the networking is going to be updated so that that service is still reachable. Okay, even if it changed host. Okay, and then you can do distributed logging, so you can do kubectl logs to access the logs of each of the container which is running, and then you can do extra monitoring. Okay, you can inspect all the resources. Okay. Okay, so for example, okay, so you, okay, so let me see. Okay, let's see a few examples on this interacting with the Kubernetes services. Okay, so kubectl get node. So here, kubectl is still running on my laptop. Okay, so from my laptop, I can run Openstack to command the Openstack virtual machines. And then once I have, and basically I use that to have Kubernetes running, doing the OpenStack COA cluster create. Now I have Kubernetes, then I can do kubectl to command Kubernetes. Okay, so for example, I can, and kubectl has kind of a different syntax. Okay, so for example, this is very similar to OpenStack server list. Okay, but OpenStack server list is from the OpenStack point of view, okay, from the underlying cloud services. Here is from Kubernetes. Okay, so if you do kubectl get nodes, you find the two nodes that are running, okay, the master node and the minion, the worker node. Okay, and here is the most used command, which is kubectl get pods. Okay, so the pods are the what's called pods. Just I'm simplifying a bit, but let's say that pods are containers. Okay, so if you have some pods services running on your machine, okay, so let's I think it's more interesting if I look here. Okay, so if I do kubectl get pods, okay, here it's showing me what are the pods that are the containers that are currently running on my Kubernetes cluster. So you see here, this is all NGINX. So this is the web server. So this is a JupyterHub deployment. So on JupyterHub needs NGINX to handle the web connection. And I scaled this service up to have five instances of this running. Okay, and you can get more information out. Okay, so I did -o wide, and here is also telling me where that pod is running. So you see that there are some of them that are running on master, and some of them that are running on minion. Okay, so okay, so now so now you want to deploy a service. Okay, another thing, so kubectl is the lower level interface. So if you're familiar with Debian Ubuntu, it's a bit like dpkg, so you install a single package basically. While Helm is more of the package manager, okay, more like apt. Okay, so here, so kubectl is if you want to deploy a single server, then kubectl is fine, but a lot of the more complicated setups are done with Helm, because with Helm you can have multiple Kubernetes resources that are created at the same time. Okay, and for example, JupyterHub, the Jupyter team provides JupyterHub as a Helm recipe. Okay, so you will do Helm install and then JupyterHub. Okay, so here we are installing NGINX ingress. Okay, so it's basically the NGINX web server. Okay, so you see, once you have Helm installed, then you're gonna get some pods running. So you see that they are the same pod that I showed you before. And then, so you can imagine now that inside the Docker container, the Docker environment of one of the machines, okay, we have this NGINX service running, okay, and if we have a user that's connecting, can access this web server, okay. But if but generally you are not specifying where, unless you have other requirements, you don't specify where you want to run a container. So a container could run on some other worker, okay? But this is no problem because Kubernetes automatically handles all of the networking. So even if the laptop, even if the user is connecting here on the public address of the master node, still there is all the forwarding done properly so that this service is still reachable from the outside user. Okay, so let's see an example of how resilient is this setup with Kubernetes. So for example, you can delete a pod, okay? So if you do kubectl delete pod and then the name of the pod, and you see that, for example, here, then I do kubectl get the pod, and I get the notification that the one of them was deleted, and you see that a new one is created, it's being created, okay? Because how does Kubernetes know that we want this to be created? Because it has another thing, another type of resource, which is called a deployment, okay? A deployment is a higher level resource that basically creates and scales up and down the pods on demand, okay? So instead of creating directly a pod, okay, we can create a deployment that the deployment is saying we want to have one instance, one container of both the controller and the backend running all the time. So if one of them dies, then Kubernetes knows that this needs to be recreated immediately and does that. Okay, and this is okay. So to be more resilient, instead of creating a single pod, you create a deployment so that your pods, if they die, are automatically recreated. Okay. Okay, and those deployments, you can also scale them. So for example, if you need multiple copies of one container because you want to be able to handle more load on your machine, on your setup, for example, okay, you can call scale and you can ask how many replicas you want. So let's say you want 5 replicas. And now you see that if you do get deployments, you see that you have this backend that now the number of pods that you want to run is 5. Okay, and then this is exactly what I did on my terminal here. So you remember that we had a lot of NGINX backends running. Okay. Okay, very good. So next we'll, okay, I'll take a look at questions now on using kubectl. So if you want to have the details on how to set up kubectl, you need a couple of commands, and they are on the blog post for reference. Okay. Okay, so yeah, for some How frequently does a pod, so there are a few questions, does a pod or node fail? No, it's pretty rare that we have node failures or Jetstream, but sometimes there are some nodes that go under maintenance, and so that could happen, but it's pretty rare. Okay, I see. Oh, thank you very much, Martin, for answering that. Okay. Oh, some other uses. Okay, so some other. So another way of useful thing you can do with the JupyterHub deployment. So instead of being it for a workshop, you could deploy it for a research group so that they have a consistent environment. They can just log in and do their analysis. And another, on top of that, basically you can deploy any Kubernetes services. So I just work on a few projects, so I don't know exactly. I don't know what other people are doing with OpenStack or Kubernetes. That's more a question for the Jetstream people. Yeah, I don't have a wide vision of the different usage that people are doing. Okay, so I showed you how you use kubectl to interact with this Kubernetes environment. Okay, and finally, we want to actually deploy JupyterHub. And JupyterHub is just another Helm recipe. Okay, and so you see here you do Helm, and then you can do Helm. This is a So you do Helm upgrade install. Okay, upgrade -- install is used so that you can run this multiple times and you can change some of the configuration options. And Helm is going to reconfigure the system on the fly. Okay, so let's say that you want to give each user 1 GB of local storage, and then you say, no, that's too little, let's do 10. Okay, then you don't need to redeploy all the services. You just rerun this, and it's going to just change what's needed. So just the configuration of the hub. Okay, so so you see, you specify some configuration options. So basically the version of the JupyterHub recipe. So this JupyterHub recipe is the one which is provided by Zero to JupyterHub. So if you Google Zero to JupyterHub, that's a great resource. And there is plenty of documentation on deploying JupyterHub on Kubernetes. Okay, so basically so my work has mainly been focused on adapting that to run on Jetstream. Okay, so having a Kubernetes environment on Jetstream and prepare it to have this recipe. But on the recipe itself, it's very well. So all the environment is abstracted away by running on top of Kubernetes. So works very well as it is. Okay, and you provide some configuration options through YAML files. So let's take a look at an example of that YAML file. Okay, so here you see hierarchical. So for example, here at the top there are all the configuration options for the hub. Also the actual container which is running JupyterHub, and then here the single user. Okay, the single user is the environment which is running all the user, all the notebooks for all the different users. Okay, so once, and here, for example, you can configure the kind of authentication that you want to use. Okay, so now by default, we are, for example, by default, this is running the dummy authenticator. So the dummy authenticator, you put in any username and it just logs you in. Okay, and then you specify how much memory you want to give each user, how much CPU resources you want to give to the user, and then the storage. Okay, and you can configure all of that and then run Helm, and this is going to install all the necessary services. Okay, And here is for an example of the resources that are running, that are created by that. Okay, so you see that there are some deployments. Okay, so the deployments make sure that if one of those services dies, then it's automatically created somewhere else. Okay, so you see the most important resource are the pods, and here we have 3 pods running. Okay, those are 3 containers that are running somewhere on the cluster. And so you see when you, the hub is the container which is running the actual JupyterHub software. And then the proxy is just handling, is a part of JupyterHub as well. And it's basically handling all the routing between the JupyterHub and all the different containers that are running the user pods. Okay, and then the user pod. So you see Jupyter Zonca here. This is the pod which is running the actual Jupyter notebook for me. Okay, if there are multiple users connected, then there are multiple pods running. Okay, and each user has a persistent volume. So this persistent volume is managed by Openstack. So you see that there is a lot of interaction between Kubernetes and Openstack, which is running below. Okay, so when a new user logs in, Kubernetes asks Openstack through the API. So basically, Kubernetes internally is using the Openstack API to create services which are used by Kubernetes. So the user logs in, the Kubernetes asks Openstack to create a volume for the user. This volume is attached to the instance which is running the pod, okay, and is mounted into the pod, okay. When the user logs off, okay, after some time that the container is idle, the container is killed, but the volumes remains there, and next time that the user logs in, can log in on any other node of the network, of the cluster, and then that same OpenStack volume is mounted back so that the user has always their own data through multiple sessions, okay? Okay, and so once you have this running, okay, so you can log in. You see here I'm connected to Jetstream, and you see that I have my Ubuntu. I have another Ubuntu release, okay? So this is not the Ubuntu provided by OpenStack. This is a Ubuntu container, okay? This is a Ubuntu container that's created by the JupyterHub, maintained by the Jupyter people, that has, and then you can customize this and use any container that you need with all the software environments needed for your workshop, for example. Okay, and you see that the user is Jovian, so that's standard on the Docker container created by Jupyter, and then you see that's running inside Docker. So this is a trick to find that you are running inside the Docker container. Okay, and this is the full setup. Okay, so you have some NGINX servers that are running on top to provide routing. Okay, then you have your JupyterHub container, and the JupyterHub container has its own volume mounted, for example, to store the database of users. And then you have the user notebooks that are running on some other machine, and they mount their own persistent volume, okay? And then all of this routing is handled for you, so that once laptop, so user 2 connects to here, authenticates with Google, GitHub, or Ecss, whatever, okay? And then once they are authenticated, they are connected. So another pod is spawned for them somewhere on the network, okay? And they are running over there, okay? Okay, so let's see, for example, live here. So if I do kubectl namespace JupyterHub, so namespace is a way of grouping containers, okay? I do get pods, so you see that what's running, my user pod, and then the hub and the proxy. Okay. Okay. So for reference, I'm gonna check for questions now, but just here. So I have the step-by-step tutorial. So if you want to look at that, and then if you have issues, you can open an issue on the repository that has all the configuration files. That usually. Otherwise, you can email me. Okay. Now. Okay. Oh, thank you for the link to the Zero to JupyterHub. Using Kubernetes. Yeah, I wouldn't know anything about, yeah. Okay, authentication and authorization on the JupyterHub cluster. So you install, so for example, by default, as soon as you start your JupyterHub deployment, you have a dummy authenticator, but then you can install, there are plenty of authentication plugins for JupyterHub. You can use Google, you can use GitHub, and so on. Okay. Okay. Okay, we are on top of the hour. Yes, so if there is any other questions, someone wants to unmute, but yeah, basically the tutorial is finished.
Quick question at the very bottom of the group chat, but would we be able to download the slides at all, or should they stay online primarily?
The slides?
Yeah, like the
slides,
presentation.
Yeah. So you can get it at this URL. Okay. And then you can download the PDF or anything. Okay.
Thank you very much. I wanted to make sure I could download these slides. Thank you. Yeah. But yeah. So if you want to reproduce what's been done, you should look at the tutorial. So the slides is basically more for an overview. Okay. Any other questions? Okay. Okay, thank you. I think we can close the presentation. Bob, do you want to do any last word?
Yeah, can this be sent by email with the link? It's hard to, it's impossible for me to type.
Oh yeah, yeah. I'm sure that yeah, Bob will make it available.
Okay, thanks.
Yes.
Very interesting. Thank you.
Thanks, Andrea. Thanks, Bob.
Yeah. I think maybe Bob wanted to say something, but yeah, we cannot hear him because it's breaking. Okay. Thank you very much, everybody. Goodbye.
Bye.